Hello, everybody, and welcome to Sparring Partners. And today we're going to talk about AI again. And there's been a lot of previous podcasts that focused on that. But today we're going to talk about something that has not received as much attention as I think it should. And I think you'll be convinced by the end as well. So I did one on the impact on the RAN, on the impact of AI traffic on the RAN, and we talk about other issues about AI. And most people talk about how AI is going to impact data centers. Obviously, there's going to be a massive impact. Today, what we're going to talk about more specifically is how is that going to impact transport? So data centers, check. RAN, check. What about transport? And I'm talking to Kristian Toivo. He is the executive director at TIP. And it's going to be quite interesting and revealing conversation, I believe. But before we do that, Kristian, welcome to Sparring Partners, and tell us a little about yourself.
Thank you, Monica. It's great to be here. Thanks for inviting me. And I always listen to your podcasts, and they always bring some interesting angles to topics that are highly relevant for us professionals in the industry. Talking about myself, I'm maybe not the best person to talk about myself, but I've been more than 40 years in this industry. Amazing. And I've spent a lot of that time in research and development. I worked at Ericsson for a long time, more than 30 years, but I then also moved into sales, and I've been part of implementing, selling, and defining the way of implementing both 2G, 3G, 4G, and 5G. So it's been a long journey. And the last 3 years, I've been working as executive director of TIP. TIP, or Telecom Infra Project, is a trade association, non-profit, that works with a set of global operators as well as industry participants. We have about 200 members at this stage, working with the global community to drive the technology development in practical ways forward, demonstrating new ways of implementing things that are relevant for the industry in change. And we do it through initiatives that we call project groups. We have about 6 of those initiatives in TIP today, spanning from transport networks to RAN, Open RAN, to telco AI, Open Wi-Fi, and so forth. And obviously today we will talk about a few of them, but maybe with the most focus then on the transport networks. So yeah, great to be here, and let's get cracking, as they say, Monica.
Absolutely. Yeah, no, that's okay. So let's just get started because TIP is not really mostly known for transport. And
Mhm.
so I like to see, why you get into that. But so let's talk about, AI. Clearly, it's going to have a massive impact on everything we do. Everybody talks about it, but not so many people have been talking about transport. So maybe you can put like what's the big picture? Why do we care about transport? What's different in transport rather than data centers and RAN?
Yeah. So you were right in your introduction that there's a lot of focus on the data centers for obvious reasons, because the size, the sums involved, the energy consumption that is challenging, and people are working to meet that up, as well as all the physical aspects of it. I mean, we see all those pictures about data centers hosted in tents and whatnot, and that is super exciting. As we all know, data centers right now are obviously used to train those large models, the foundational models, and that we believe is going to continue for the foreseeable future, if you like, as this technology develops. There's of course also a discussion about as AI-based services or inferencing reaches the market at scale, where is that inferencing going to happen? And there's a lot of debates, and we can talk a little bit more about that in a second as well. But I mean, coming from the practicality point of view, I mean, these data centers start to be so big that first of all, it's not trivial where they are placed, because they need to be placed where you have energy and cooling and facilities available, which means you have to connect them. But there's also this kind of view that the data centers are becoming so big that actually you have to distribute them between multiple sites. And obviously you need to connect them to each other. And you have particular requirements on the connectivity. And that brings me to the fact that from transport network point of view, obviously transport networks are essential in connecting all our telecoms capabilities and components and nodes into a functioning network. And there's been a long tradition how that technology, transport technology, is evolving as data needs have been increasing in our traditional telecom services. And we've moved into IP, we moved into optical, and there is a lot of initiatives ongoing trying to move the technology to be purely optical in terms of not having any conversion between electric and optical signals anymore, all in the name of efficiency, speed, and economics. But what obviously has come in the last couple of years is the fact that the traffic associated with data centers and AI is putting even additional requirements on the technology, and that has, in my opinion, to some extent got less publicity than some of the other aspects that you mentioned earlier when we started the discussion. And why is that? Maybe that is because telecoms and our industry is usually very siloed. Folks work in their specific domains, high level of expertise. It's very unusual that people move between these domains. I can speak for myself. I'm a core network person who eventually learned to talk about and deal also with radio and RAN. Never kind of had the opportunity to work hands-on on transport networks, which means my contact network and the people I've talked to are not always, outside of the comfort zone, if you like. But having said all that, connecting this back to TIP, actually from the start of TIP in 2016, transport networks and particularly optical transport was seen as one of the key areas to be developed. At that time, maybe not so much in consideration of AI, but more as a response to the fact that there was a continuous increase of data being transported in the networks, whether it was through increasing speeds in mobile networks or just increasing wireline speeds, which all has to be then connected in the backbone and mid-haul and front haul and all these aspects of the network architecture, which is served by transport network technology. And TIP focused very much on the optical transport technology. And there's been, over the last 8-9 years, so 10 years, a continuous journey of defining operator-aligned requirements on how this optical transport should evolve, what the product requirements would be in the context of an evolving architecture, and also then validating, testing, and badging those solutions. And I'll come back to a few examples of that in a minute. And in one of our Fuse conferences, I can't remember now, it was the last year or the year before, we had one operator representative, one of the co-chairs from our optical transport team, who basically stated that without this kind of approach of working on an architecture and product evolution as determined by the TIP project group, they would not be able to keep on investing in the necessary transport capacity. So obviously by working in an open fashion, which obviously TIP is always about open, and also disaggregating, basically separating hardware and software to enable alternatives and choices, that has led to an ecosystem evolution which has complemented, I would say, the traditional incumbent players offering in the transport network side. And particularly the focus has been to create a flexibility in so-called pluggable optical modules, which would enable operators in a flexible way to add capacity and choose hardware, software components based on their particular needs that match those overall architectural and functional requirements that this team and joint group of operators inside TIP have defined as those priorities. And actually earlier this year, we announced, actually it was in connection with Mobile World Congress, we announced the result of one of those initiatives and projects within the transport community of TIP, where 400 gigabit transponder, pluggable module with hardware software disaggregation that had gone through very stringent validation by MTN in South Africa and NTT in Japan, was kind of given what we call a gold badge. So basically this solution had been tested in real traffic, and we saw some announcements later this year, just before the summer or during the summer, where NTT also had placed commercial orders on volume deliveries of products fulfilling these requirements and matching this transponder technology that had been validated within TIP.
So, yeah, so let's just sort of step back. What should we expect in a sense? So, Open RAN already kind of got us more interested in transport than we were before, because initially everything happened at the edge. I mean, or, well, I shouldn't say that, but, there was less, I guess, transport was just basically to do the basic stuff that we're used to. But now, obviously, there is more, because the more you move stuff to the cloud, even without AI, the more of a needed transport you have. And then with AI, it's going to be worse. So how much of a change is that? In addition to the addition, so traffic is growing regardless of Open
Yes.
RAN and AI and everything. So there is that. But also, what is that AI is bringing? I mean, how much of a change is it?
Yeah. So going back to where we started with the data centers and distribution of data centers, beyond, like you rightly say, the ever increasing capacity and needs, I guess one of the key things that people are looking at, and we are looking at that actually in TIP, as well as I know other industry organizations and consortium are looking at that, is what particular requirements are there to be able to basically distribute, you can say, the functionality, whether it's training or inferencing, in a smart way between data centers in such a way that the transport network is not creating any challenges with that. Beyond the capacity and speed, it's obviously about latency, jitter. There are very stringent requirements when you work with these AI payloads in those data centers. And that is a particular requirement that comes on top on that ever increasing traffic. And I think right now it's very much focused on, deployment scenarios, which initially are moving from, very central data centers, large data centers, to eventually distributing them, first of all, because, as we said earlier, you can't just keep on making them bigger and bigger. So you have to split them up or distribute them. And to your earlier point, this is obviously something we will all as an industry follow up on and understand as things are driven by the usage needs. How does all this capability, maybe not so much of training of AI models, but particularly the inferencing, how much and when does it move towards the edge? And as a consequence, those similar requirements then on the transport networks would also kind of be further accentuated. I think this topic about the distribution and the edge, there's a lot of different views and scenarios that are being worked on. And I think, as always, it would be very much dependent on the use cases, which I guess today we all know it's kind of early days, and maybe we see more of the usage moving right now based on fixed network connectivity. Obviously, enterprises using AI in their offices. We know that consumers use a lot of their services at home over Wi-Fi, which means also fixed network connectivity. But I think there's no doubt that we all believe that there's going to be also an increasing amount of usage of AI services from people are on the move over their mobile phones, and the transport network uh, requirements and needs will follow this journey. And then, of course, the actual data center and processing and compute platform evolution towards the edge will follow this journey based on those market and user needs and use cases.
Absolutely. So there is the question, I guess, is also how to think about, the sort of more distributed sort of what is at the edge and what is centralized, and that depends on issues like latency, what is it you're trying to do, and what is the transport infrastructure and the cost of that. Because
Mm.
if transport exists but it's very expensive, you might want to move everything more to the edge because then you have to pay less for transport. So that's another thing, and and also the question of availability, and so what you're doing with it, who is doing it, and what is the cost, because the cost of electricity or real estate is not the same. So if you so, and in fact there is a business opportunity for operators like in the US, like Verizon, where they have a lot of they have some room in the downtown areas where the central offices, which they no longer need, they have room there, which can be used for some at the edge facilities. So that might be some other way to do it. So there are different ways to do it. So there are different moving parts.
Yes,
And
absolutely.
so the question is that how should we think about it um, in terms of, because, well, I guess to some extent we don't know, but how should we plan for it, or how should we face it?
Yeah, yeah, that's probably, Monica, that's $1 million question, and a lot of people
Yeah.
are
Mhm.
discussing and debating that. I think there's no doubt about, and that's maybe why also referring to the work we are doing in TIP, we have been and we are focusing very much on how do we evolve that work in the transport network that, as I mentioned earlier, has been quite successful in bringing out or developing a new ecosystem and new approaches on how to build out and match the capacity need. How do we now follow the AI trend? And one of the key things is this, where we already see and know that the data center, the inter-data center traffic, so when you have distributed data centers, how do you best connect those together? And I don't think there's any doubt that there's a market for that with high capacity, low latency, and hence that's kind of a given or a problem area that should and can be tackled. And as I mentioned, we within TIP, and I'm sure in other instances as well, people are working on that. I actually just saw before this call, I get these newsletters from various places, and there was a announcement by a set of vendors working together, trying to tackle this problem. By the way, the same vendors being also active in TIP group, addressing the same. So clearly that's an identified problem. I think what then we need to think about is how far will the distribution of data centers go? And again, I think we need to make a difference between data centers where you are training AI models, which come with significant amount of computing power as well as data that has to be um, ingested and worked with. And then on the other hand, how does the actual usage of AI, this so-called inferencing, how does that evolve? Because the two things, in my mind, are not necessarily evolving in the same way. We see now the huge investment and focus on the training. And there are a lot of people in the industry, experts in that domain, who see that there is a certain limit how much you need and want to and can distribute that. We have those parameters you mentioned earlier about electricity and so forth. But there is a limit to how much you want to distribute that. The interesting question is then the inferencing. And of course, inferencing requires also low latency, jitter. But there are also different technologies at play and different opinions about how much do you need to transfer data between the actual end device, which is kind of the user interface to using AI versus on where you actually are then processing your requests, doing that inferencing and getting the responses and solutions, conclusions that you are looking for. And I think that, to my understanding, the debate is still out, and there are people who see a significant impact on traffic related to inferencing, particularly from consumer devices and people
Mm.
on the move, which obviously would be associated with mobile networks, which then again would put a lot of focus on the transport network, on the front haul, mid haul, and so forth. But well, backhaul, sorry, front haul is obviously radio, but backhaul and mid haul. But there are other people who say there are mechanisms where you are only transferring the necessary differences in data, and actually you can do that further back in the network. You wouldn't have to have all that at the edge. So I think there is the jury is out. I think it's clear there's going to be an impact, but what the impact will be, particularly for the usage, I think it's too early to say, as it looks like. I mean,
Yeah.
and people are very careful also drawing too strong conclusions because we are at such an early stage of mass usage of AI that remains to be
I
seen.
don't know. Yeah. So, when I did the podcast with Sean Kinney at RCR, we sort of came to the conclusion that obviously the jury is out. However, if you look at what we do, or, I mean, like the two of us, or the users, is that when I do a search on ChatGPT, basically I got ChatGPT to use a lot of capacity or a lot of up out in the crowd, but then it just sends me the summary, so it's actually not
Mm.
that much of a difference, because instead of me doing and going back and forth, it might actually be less traffic because I get everything in a more efficient way. So I would say maybe, from a personal point for that kind of thing, there is no change. However, if you have a situation where it actually needs to use real-time data. So for instance, let's say you do RAN optimization. I'm just saying this because this is something I'm working on right now. So
Yeah.
in order to do RAN optimization, you have a model that is trained. That is just happens in the data center, pretty much. So not much of an impact, maybe. But when you do the real-time optimization, the data center has to get real-time data from the network, from each cell, each, whatever happens, each user, and then optimize it. So other that is done at the edge, and a lot of it is going to be done at the edge, but some of it will not. So there is that kind of data that I think it might just make a huge difference, because also it comes with latency constraints.
Yeah.
So
So that example, if I may, that
how,
you
I
just
mean,
mentioned. Yeah.
how do you see that kind of like
Yeah.
the kind of data that it just needs to be going back and forth because it's real-time data?
Yeah. So I do actually think that the case you described, the use case where you actually use AI for real-time optimization of the radio performance and over the air interface, that in my mind would happen in the base station of the future. Using O-RAN terminology, probably would happen in the digital unit in the DU or in the baseband, if we talk about classic RAN functionality. And the idea would be that we have models that are trained and we find ways of implementing the necessary functionality in that actual system that is offering the RAN, however RAN will look like. And I think this is very much a 6G topic, which people are working on right now. And I'm not so sure that there would be a massive real-time transfer of information in that case. I think it would be not even feasible if you think about a big normal network with 70,000 sites, which is a typical, countrywide mobile network. So you wouldn't do that in a data center. You would actually do it on site based on pre-trained models, based on the type of RAN implementation that is basically AI native. And there's a lot of debate, obviously, what you need to do that, what type of compute platforms you need, and all that. And that's probably a topic for another podcast with other people.
Yeah.
But I think where I do believe there is a question on how the data would be transferred and how much data would be transferred is use cases that involve video, and they would very much be associated with us as users, consumers, wanting information either based on what we see, which then needs to be transferred over the network. If you are on mobile, it would be on uplink, which is kind of today less
Mhm.
used than the
Mhm.
downlink. So there is a question on how the
Mhm.
uplink would be impacted. But then, of course, the question is where will that data be processed? And if you have good transport network, you probably would do the so-called inferencing and conclusions and send back basically additional information, guidance, or modify your data, your video view. For example, if you use smart glasses, that
Mhm.
would be done uh, depending on your transport capabilities, either closer to the edge or further from the edge. To your earlier point, it depends on what type of capacity and implementations you have in place. And I think these particular use cases are maybe not so well understood yet because they depend on actually what we as consumers and users, and it's not only consumers, there's obviously lots of professional use cases associated with video that you can just imagine, anything from maintenance to construction to healthcare to various type of things. Some of them where you would have a fixed network connection, but many of them also would require you to have this capacity for AI systems over mobile networks. And I think here the question will be, what is the amount of data that will have to be transferred back and forth? And how much of processing will be done in
Mhm.
the device? And will it be then complemented by processing the edge or further up in the network, again, dependent on the exact requirements and, of course, the infrastructure and transport network you have available for that. So that's why I'm saying I think we will probably have to see how that will all evolve. And we'll probably see different ways of implementing it as well, because as you and I talked earlier, depending on where you are in the world, you have, much more advanced or less advanced, you know, capabilities on transport networks all the way to the edge. And we know for a fact that in many countries in Asia, for example, there's been a significant deployment which allows you to centralize your processing, whether it's for your RAN workloads, talking of mobile networks, or potentially AI workloads, whereas in other parts of the world we don't have that because of geographies as well as history. We might not have that transport infrastructure, which means there would be needs of having solutions that process this data closer to the user. And I think this is going to be really interesting how that will all evolve over the next
Yeah.
couple of years.
Well, and it's interesting because I know when I'm talking in some people in Asia, that they're actually thinking of having the data centers even in outside the country. So it's like outsourcing. Open AI, I think it just announced building a big data center in India. So there is also like I guess for kind of training purposes, it doesn't matter where that is. It could be just as
Exactly.
far as
Yes.
it can be on the moon for all we care.
Yeah.
But um, the question is that okay, so assuming we have more traffic, we need more infrastructure. Who's going to pay for it?
Yeah. That's probably the other $1 million question. that
Yeah,
that
I'm just gonna go for the
yeah.
high value questions.
Yes, yes. No, absolutely. That's a highly relevant question. And that comes back to one of the other things that we have been working on in TIP. It's a good segue. So we have this, what we call the telco AI group, which is kind of working very much on use cases that are relevant for monetization of AI uh, by telcos, by operators, hence the name telco AI. And I think currently the focus is very much for very practical reasons on what role and how could operators, telcos, monetize, benefit from AI in terms of offering and bundling that with their connectivity to enterprise users. As we know, many of the operators, some of the ones you mentioned, they have very strong B2B, business to business arms divisions. And a typical operator might have 20 to 30% of their actual revenue coming from business customers. And it's an obvious kind of approach to see in what are those use cases where there's a benefit of the operator offering either the full AI services in connection with their connectivity to enterprises. And of course, that can be both fixed connectivity and mobile connectivity, or maybe in also many cases in partnerships with various other companies that can provide the final service, but there is a role to play for the operator in terms of enabling, not the least also from a security and trusted point of view, enabling those capabilities for enterprises to purchase through operators. And I think that's one way, if that monetization actually takes off, that of course will then also feed into paying for that infrastructure that is needed to provide those services better than before. I think if we then take the step back to kind of the more generic opportunity and use cases we just have discussed about, let's say, as consumers, users, using AI services at large volumes when we are on the move, it's very hard to believe that there is a simple monetization, or let's say that directly connects that usage with funding for investing in networks. And I think that is a challenge that will have to be dealt with. I mean, I think if you read just the news as you and I do every day, you can see that at least there's statements that the return of investment on AI services is still very low, even from those that are developing and offering those services, which might or might not be a challenge on the long term, but that there's clearly not so much revenue to be distributed right now. It's an investment phase. But as soon as we come to a situation that we have discussed, if that would require significant investment in networks, the question will come, who's going to pay for it? And I personally, my view is that it's going to be probably more complex than we think, which means we will have to look for smart solutions that optimize the capacity you need in terms of, so where do you place those inferencing services in a way that you don't on one hand need to excessively invest in transport, but of course there are other ways of reducing the data that you transfer. So there probably will be different ways of distributing the processing between the end user devices at the edge, as well as the data centers, because the money probably would not exist to just kind of do a massive upgrade of network infrastructure all the way from the access network to the backbone for all these use cases. So I think the outcome will be far more messy and complex than maybe in a perfect world where you could just put in a lot of capacity and everybody would be happy, because to your point, somebody's got to pay for it.
Yeah, it's not a perfect world. We know that. We know that
Yes.
much from all the previous. Actually, since we're not in a perfect world, well, actually, okay, sorry. Let me ask you. So this is like the funding part. From an architecture part, what is there something that we need to do? And I guess that's where you're coming in as Tepic in terms of, do we need a different way to think about the transport in the way it's organized in terms of having more disaggregated, more open, that would help us deal with the traffic increase?
Yeah, and I do think that a lot of that thinking is actually ongoing, some of it in TIPS initiatives and of course many other initiatives that are ongoing. And there is this, I mean, the original idea that was kind of the basis for the work in TIP in our optical transport initiative in project group was to kind of create ways of being more flexible, being able to kind of focus innovation on software and hardware separately, to provide flexibility in how you expand through pluggable modules. And I think all of that is, to my understanding, going to be an equally relevant piece on how we evolve in an AI era transport networks. We just see that the capacity demands and the specific functionality demands for AI, put additional requirements on what to do, but it doesn't kind of remove the fact that the way to be open, flexible, disaggregate seems to be at least one feasible way of responding to this. The other thing is obviously how do you orchestrate and steer, and that kind of is a segue back to AI, and that's also work that is being done, of course, in TIP's transport network group, but also in other fora. Once you now have an open, flexible platform that is kind of able where you can flexibly increase capacity, how do you orchestrate that in such a way that you use that capacity in an optimal way, that you kind of configure in near real time based on the needs? And in that sense, the work that we've been doing in TIP is not just about creating, new modules, capabilities to do kind of faster and more high capacity transport. There's also been an orchestration or management architecture that has been developed in order to be able to kind of add AI based applications with which you could optimize the way you manage and orchestrate that transport network. Not that different from the discussions and the work that is being done in the RAN space when it comes to, particularly in the automation, when you use Open RAN interfaces with the SMR RIC platforms. How can you bring in intelligence in terms of applications that would help in near real time to optimize how you steer your network? And I think we are at a very early stage of that, but there's no reason that we wouldn't, as an industry, use AI in a very efficient way, both in the transport network and in other parts of the network, to get the most out of that capacity in a flexible way. And that's one way to kind of tackle it, using AI to deal with the impacts of AI. That's kind of a funny way of looking at that.
No, absolutely. Yeah, it's AI on AI and AI, and it just goes on forever. Unfortunately, our time is up, but and so we didn't get to talk about Open RAN. But
Yeah.
what I would say to everybody listening is that they should just go to Fuse in November in Dublin, and then they will hear about what's new and coming. I know there's a lot of new things that you're going to be talking about. So we have not, but maybe we'll have another podcast and talk about that. But in the meantime, I think we have a lot of food for thought here in terms of thinking about what are the transfer implications, what can we do about it.
Yes.
That stem from adoption of AI in the data center. So, Kristian, thank you very much for sharing your thoughts with us and tell us what's coming up at TIP.
Fantastic. Thank you, Monica. And as said, the Fuse 3rd, 4th, and 5th of November in Dublin, we will talk about these transport network topics, RAN topics, and AI topics, all those topics that we touched upon more or less in this conversation. So looking forward to having everybody join us, and we will talk more about that later on.
And there will be a link in the podcast description. And thank you all for listening. And do subscribe to the feed and let people know about Sparing Partners if you like. Thank you so much.
Fantastic, Monica. Thank you.